Okay, this is the current setup of the circuit. As you can see, this register is 10,000 ohms, and this resistor, this resistor is 10,000 ohms, and this resistor, which is connected to this one, is 2,000 ohms. Here, this front red wire is connected to 5 volts, and it runs the current all the way through to ground. So this is 0 volts, and this is 5 volts. Here, as you can see on my computer, I have serial monitor open. This is collecting the input analog voltage, I think, and then it's using that to calculate the actual voltage being read. And this is working through the voltage sensed by A3, as you can see in my code, because I made the pin mode like A3 input, and then I also made A3 the pin to an analog read, and put that analog read into read input and do the calculations, and put it into output voltage, which is a double, which is a variable, and then after that I print that out in my serial monitor, if that makes sense. Okay, so currently all these values here, they don't I hope you guys can see it. I don't know, I'm not too sure, but currently all these values here don't really correlate to anything, because as you can see, this is my A3 pin. Nothing is plugged in. My A3 pin, I will now plug in with a orange wire. Is that in? Okay. And then this other end, wherever I plug it in, it would read the voltage from there. Okay, so now let's take a look at the breadboard. So there are 3 connections connection points that we could test. Wait, actually, let me move A3 out of the way. We could always plug it in later. So here we have this row, which tests, because as you can see, for the wire for A3, one plugs into the A3 pin, right, which takes in the input. The second tip of this wire could be plugged in anywhere. This tip, I'm just trying to be clear, guys, but the second tip, it calculates the voltage through the code, and that voltage is immediately displayed in the serial monitor in this part of the computer. Okay, so where can we put the second end of the A3 wire, right? We can put it... Okay, this is the next day recording. I did an explanation the day prior, but I think it wasn't good enough and it wasn't as clear, so redo explanation. This is a diagram of my work while I was making the circuit. As you can see, my work is separated into 4 sections. So the first section is a diagram of what the circuit looks like. The second one is the equation. I think it's called Ohm's law. Loki, I forgot. I should have remembered from class. And the third and the fourth is the actual solving of the problem to see what I should expect for the voltage detection in the circuit for my code. So the third is finding the current, and the fourth section is calculating the expected voltage for the points. I will discuss this in 1 second. So to make this more clear and crisp, because I think my picture of my work is not clear enough, this is what my pseudo circuit looks like. So here the arrows show the direction of the current. In real life, it's the opposite way because the electrons flow from the negative to the positive side of the battery, but in this pseudo diagram, we're going to use this convention. Okay, so now we're going to take this pseudo diagram that I had on my sheet. On the left side, which I made it really crisp and clear with the diagrams, and translate it into real life. So I have my Arduino on the right side on the bottom, and I have my 2 resistors here. Okay, so now they're connected by this red wire, right? from the 10k ohms resistor side, you see that it's connected to the 5 volts part of the Arduino. And to close this circuit, oh, by the way, the resistors are also connected to each other for the current to run. On the 2k ohms wire side, it is connected to ground. Ground means 0 volts, so it directly mirrors the pseudo circuit on the left. Okay, so let's talk about what we're trying to do with our program. We're trying to see, number one, what voltage points can we test within the circuit in real life? And we will see this here. So here are the 3 different positions we can test in real life for the voltage, right? We could get the voltage in real life. So A is the connection point between the 10k ohms resistor and the 5 volts battery that the Arduino is producing. So that's the first connection point. The second connection point is B. That is the connection between the first resistor and the second resistor. First resistor being 10k ohms, second resistor being 2k ohms. And the third connection is C, which is between 2k ohms and the 0 volts on the Arduino. That's like the full circuit, if that makes sense. Okay, so now let's get to solving, right? What the voltage we would detect between A, B, and C is. So starting off with like our Ohm's law, step 1, we're finding the current. We know the voltage, and we're given like all the resistors like values in this system. Here, like in the equation, we could just add the resistances because they're in series. I kind of wrote it down in the slide, guys, meaning that the current does not split its path. The current is in one consecutive loop. So after finding the current, we are going to find the voltage drops, right? So you have to think about voltage like okay, in our system, we know that we're putting in 5 volts, and then at the end of our system, we should end up with 0 volts. Like think about like money. Like you go through this path and then you're like spending money. You know what I mean? So we're trying to see like, okay, if we're walking this path, we're starting from 5 volts, right? And then we're visiting the first resistor. Also, I like put like R1 and R2 next to the resistor so you could differentiate them. So you're going to the first resistor, we visit it. So how much voltage are we going to lose? So we're using this equation of like this modified Ohm's law, V1 times the current. No, V equals to the current times the resistor to find how much voltage we lose after we visit each resistor, if that makes sense. So we walk the path, we go to resistor 1, and after resistor 1 we go to resistor 2. So between resistor 1 and resistor 2, we are supposed to lose 4.17 volts, right? So 5 minus 4.17 volts, as you can see in the next slide, that is around 0.834, right? Like at the end of the path, you're supposed to like have 0 volts. Like you're supposed to like spend all your money, spend all your volts, right? So the first the conclusion here, let's go to the next slide and then let me summarize. The conclusion here is, let's start off with the 5 volts. We're walking our path, right? We're spending our volts. So on path A, we have not visited any resistors. So we should have all our volts. We should have all our money, right? So we should have 5 volts. From R1 to R2, that connection point, we already visited resistor 1, which is 10k ohms. So we calculated that the voltage drop, which means how much voltage we should lose, is 4.17 volts. So we should expect that when we plug in our little like voltage tester thingy to see how much voltage is at point B, which is between resistor 1 and resistor 2, we should expect to see that we still have around like 0.834 volts, right? Okay, so then after point B, we're walking our path, right? Think about walking our path. We go to path C. That means that we visited both the resistors, right? Which means that we should have spent all our money, because at the end of the day, we should end up with 0 volts because that's ground. So at C, we should expect to see 0 volts. Okay, so now let's do the real life testing. I forgot to mention one little tidbit, which is the way that I'm testing my voltage from point A, B, and C is through my code, which I linked one of the analog pins, A3, to a wire, and the other end of the wire I will plug into the connections between A, B, C to test my hypothesis on what the voltage is. You will see in the real life clips, but here is like a visual example. Makes sense. Okay, so let's just put it to the test. So here we take our Arduino, we plug this wire to A3, and then we're gonna put the second side of the wire to test the first 2 connections by putting it anywhere in the row, and then we should see 5 volts shown in the serial monitor here. If you can see, it's all 5 volts. And this is to be expected. Now let's plug it into the second connection right here between the 2 resistors, if even possible. Oh yeah, okay, I got it. And then as you can see in the serial monitor, it's pumping out 0.82 volts. Let's see the last connection. So let's take out this wire and then plug it in here, which is our third connection, and then it should give 0 volts because this links directly to the ground. And then let's look at our serial monitor, and it all turned to 0. Also, I've been told there's like some discrepancies, like it's not the most accurate. Also, my calculations are not the most accurate because I didn't do my significant figures the way I am supposed to be and expected to be.